Welcome to MATHLOGIC classes. Here we discuss maths and logic problems of NCERT, Sheba Assam Board, and WBBSC. Okay, let's start today's class. So today we will discuss quadratic equation, and today's problems are taken from the NCERT exercise 4.1. Okay. So let's start today's class. So today we will discuss the quadratic equation, and as you can see, we will start our quadratic equation chapter with a quadratic expression, right? What is the difference between the expression and equation? So it's the simple expression. If you add equals to 0 to expression, it will be a equation, right? Okay, if you find such type of x things, means ax square plus bx plus c, and if you don't put equals to 0, so then it will be a expression, right? Okay, so here this is the basic equation you will find, right? Fx equals to ax square plus bx plus c. So this is the basic expression of a quadratic expression or equation. If you add, so don't confuse with the expression and equation. Okay, if you add equals to 0 with the expression, so it will be a quadratic equation, right? So here, if a and b, a b c be the constant term real number, so and if you uh, constant number, so the expression will be a ax square plus bx plus c. So now when you heard the name quadratic, so it should be uh, come in your mind. So the maximum power of the variable. Okay, so your constant may have a to the power 4, a to the power 5, doesn't matter. So if the variable, here the variable is x, if the power of x is more than 2, so it's not a quadratic equation. If it is less than 2, so then also it will not be a quadratic equation. So you have to keep in your mind. So for the quadratic equation, for the quadratic term, okay, for equation, so it must be, expression must be equals to 0 for, but for the quadratic equation, so remember the term quadratic, so your maximum power of the variable, here x is a variable, should be 2, not more than 2, not less than 2. So just remember these things. Okay, so if now it is also given, if a equals to 0, so if not a equals to 0, so then it is a quadratic equation. But if a equals to 0, so then are the term left? So ax square, so term will be 0, right? So the remaining term is the bx plus c. So it is a linear equation, means if you put bx equals to 0, bx plus c equals to 0, so it will be a linear equation, right? So now come to the problem. Okay, so here so I have given this name of the equation like this. So QE stand for the quadratic equation. Okay, so as we are discussing quadratic equation, so abbreviation we have written QE. So it is a exercise number 4.1. Okay, and the problem number 1, right? And problem number 1, it says check whether the following are quadratic equation or not. Okay, so we have to find whether the following expression are quadratic or not. So one expression or one equation will be there. So it is a equation, as you can see. So left hand side and right hand side is given a combination of x. Okay, here x is a variable, all of you can understand. So so uh, so the question number 1 is the check, you have to check whether the followings are quadratic equation or not. So 1 subsection I, the expression is x plus 1 whole square equals to 2 into x minus 3, right? So this is your first equation. So your left hand side is x plus 1 whole square. So it is basically a whole square function. So all of you know, I think all of you know, so how to expand it. So this is basically a plus b form. So simple. So if a equals to x and b equals to 1, so don't confuse it. I am just telling you the standard form, a plus b whole square. So you have to expand x plus 1 whole square into in terms of a plus b whole square, right? So I think all of you can understand how to expand it. So in the first term will be square, x square, plus the second term will be 2 into the first term here x and second term is 1, so x into 1. So all of you know, if you take the product of 2 into x into 1, so your product will be the 2x. So here it is written in the second term, and the third term will be 1 square, and if you square of 1, so result will be 1. So in the right hand side, so here we have multiplied 2 with x minus 3 term. So the first term will be 2 into x, so it is a 2x, minus 2 into 3, so it is the 6, right? So now you can see here, so it is the 2x and 2x, so both will be cancelled out. So what will be remain? X squared plus 1 plus 6 equals to 0. So ultimately we are getting x squared plus 7 plus 0. So now the thing is it is a quadratic equation? Yes, it is a quadratic equation, though it don't have the, see, so here I have given this is a quadratic equation, right? But here the term is or it is an expression, okay? So nothing is different. So here ax square plus bx plus c. So here you check the form. Here x square is there, but x term is not there, but it doesn't matter. Okay, as you can see, the maximum power of the variable is 2, so it is a quadratic equation. Okay, now it is a question number 2. Exercise 1 4.1 and subsection question number 2, right? So here the expression is given, x square minus 2x equals to, within the bracket, minus 2 and 3 minus x. So what we are going, we just, so here left hand side, we no need to expand anything, so it is given. So in so nothing to be expanded here, but in nothing to solve. Okay, but in the right hand side we have to product, we have to get the product. So it is the product of minus 2 and the another term is 3 minus 6. So we have just multiplied it, minus 2 into 3 equals to the minus 6 plus, so as you know, minus minus, if you uh, take product of 2 minus term, so you will get a positive, right? So here similarly happens. So we have multiplied minus 2 into minus x, so ultimately we have got twice x. So we have, again we have written the same things, and now, so here you see, so this is this term, when we pull it uh, in the left hand side, the quantity total content of the right hand side, if we pull it to the left hand side, so we have to add here 1 minus, okay, and we have written the entire term which was there in the previous line, right? So here it is given minus 6, it was given minus 6 plus 2x. So when we uh, interchange the equation, means um, we have a change, okay, from the right to the left, so we have added 1 minus sign, right? So here we consider it positive, and here as we as we change the equal sign, so it becomes the minus 1. So we have just multiplied with the minus, okay, so minus minus plus, so the we have copied this term, okay, and nothing to change. So it becomes x squared minus twice x plus 6 minus 2x equals to 0. So again, it is a quadratic equation. Why? And here the mid term also there, means x term also there, right? Minus 6 minus 4x, as you can see. So it is also a quadratic equation, as the maximum power here 2, right, of the variable is 2. So now come to the next problem. So here the problem 3, the problem is, uh, here two products are given. In the left hand side it is the x minus 2 into x plus 1. In the right hand side it is the x minus 1 product with x plus 3, right? So if we expand, I think all of you know, so x square. So then we added the constant term and we multiplied with x, then we have taken the product. Okay, so it is also a standard formula. So similarly we have followed in the uh, right hand side also. So then we simplified both the side and we get x square. In the left hand side we get x square minus x minus 2, and right hand side we get x square plus 2x minus 3. Okay, we just we have just simplified it. So as you can see, okay, so we have continued in next slide also. So ultimate, we get the minus 3x. The ultimate expression is the minus 3x plus 1 equals to 0. So here you can see there is a no x squared term. Okay, here the maximum power of the x of the variable is 1. So it is not a quadratic equation, but it is a linear equation, right? Now come to the second question, question number 4. So here also two product is given. Okay, in the left hand side and right hand side also. In the left hand side it is given x minus 3, and the product of x minus 3 term and twice x plus 1, right? In the right hand side it is given product of x and x plus 5. So we have multiplied it here. So for the simplicity, okay, we just expand. We initially we have multiplied x into second term, then minus 3 into again the second term, right? So the ultimately we have given the equation, we have get the equation after simplification, x square minus 10x minus 3. So again the maximum power of the variable here